Now let's continue our discussion for analytical chemistry, which is we are now on midterm. So we are now on the exciting part of the topics pertaining to analytical chemistry because we will be dealing with calculations. That is the reason why I prepare a pre-recorded video for you to easily access and for you to watch it again and again if you did not did not understand the process of the calculation. But don't worry, because it is very easy. If you compare it to mathematical calculation, it is in 1 to 100, it is in 50% na madali lang siya. So without further ado, let's start our discussion by our first topic or our first lesson for midterm, which is molar mass and molar volume. As we've already discussed, we've already done discussing how we can calculate a concentration of solution and how we can calculate each concentration of each solution. So today, let's proceed now on how to calculate a molar mass and molar volume. So molar mass, molar volume, and molarity, it is dealing with how much, meaning to say this three terminology will eventually explain in the chemical composition of each substances or reagent. So as I've said, it's dealing with the question how much, so meaning to say we will be calculating, or it is pertaining on measurements or numbers, and with that we will calculating each measurements and numbers or even the masses or atomic weight of each element. So let's proceed. So with that, there's a question arises how to calculate the molar mass of a substance. Very simple. Very simple, as I've said. Let's go back to the basic, or let's go back to define what is molar mass. A mole has another meaning. If you take a mole of an atom of any element, it will have a mass in a gram. Numerically, it is equivalent to the elements of atomic masses. If you take a mole of molecules of any compound, it will have a mass in a grams, numerically equivalent to the compound's formula mass or molecular mass. To explain it further, the molar mass is pertaining to the mass of a certain mole. So meaning to say 1 mole is equivalent to an atomic weight of a certain element. So to discuss it furthermore, let's proceed. The mass of a mole varies with the different substances, but the number of particles, which is atom or molecules, present is believed. Let's go back to Avogadro's number, which is be the same with 6.02 times 10 to the power of 23, and it is constant. The mass of a mole of any substance expressed in grams, it is called as a molar mass. That's why I've said that 1 mole is equivalent to a atomic weight of a certain element or a certain compound. So the second concept of a mole can be expressed as follows. So let's proceed. So this explains everything how thus 1 mole is equivalent to atomic weight, and why thus atomic weight can be called as a molar mass. So let's for example, 1 mole of oxygen atom has a mass of 16 grams. So where did we find this, or where did we get this 16 grams? Of course, sabi ko nga, 1 mole is equivalent to atomic weight of a certain element. So the element here is the oxygen, and the atomic weight of the oxygen, which is you can get it in the periodic table. I hope all of you has a periodic table. You can get it in its atomic weight, and the atomic weight of oxygen is 16 grams. Okay, and 1 mole of chlorine atom has a mass of 35 grams. The same, look for the atomic weight of a chlorine, and it is 35 grams. So here, from the element, we have a compound here, hydrochloric acid. So from 1 mole of hydrochloric acid, molecules has a mass of 36 grams. So where do we find the 36? Where do we get the 36 gram? You just add. Okay, again, you just add each element. So we have 2 elements here, right? Hydrogen and chlorine. So add 1 plus 35, which is the atomic weight of hydrogen, which is 1, and atomic weight of chlorine, which is 35. If you add it, the result would be 36 grams. Okay, so that makes, or that is the result why hydrochloric molecule acid has a mass of 36 grams. So, yan, I hope you get my point. Next, we have 1 mole of sodium chloride molecules has a mass of 58 grams. So, where do we get the 58 grams? Again, just add each element. So, we have 2 elements again here. We have sodium and chlorine. Sodium has an atomic number of 22. Okay, again. So, in my periodic table, it is 22.99. Let me rephrase what I'm saying a while ago. So, that makes it 23. Kasi, decimal ito. 22.99 ang atomic weight ng sodium. Round off, ha? So, that makes it 23 plus 35, which is in chlorine. So, 23 plus 35 is equals to 58 grams. So, in short, yun na nga, in short, as I'm saying, in short, 1 mole of any element is equivalent or equals to mass over gram over atomic mass per gram and mole. Okay, gram per mole. Okay? And 1 mole of any compound is equivalent on mass gram over molecular mass or gram per mole. Okay, so that is the unit. So that is the formula on getting the molar mass of each element or a compound. Always remember that 1 mole is equivalent to 1 atomic weight or atomic weight of each element. Okay, let's proceed or let's try an examples. Very simple, no? So how many moles are there in 29 grams of sodium chloride? Take note, guys. Even in the since day 1 that I've been discussing analytical chemistry and we are involving on the calculation, I always tell you that in solving problem, we must be able to cancel all the units in the mole mass relationship or not even in the mole mass. Yung mga past calculation natin, always remember to cancel each the same units. Okay? Para makuha natin ang unit na result or as a result of that problem. So, i-cancel lang ang the same unit. So, given we have 29 gram of sodium chloride. So, what we're gonna do, this is the step. The molar mass of sodium chloride is 58.5. Okay, 58.5 gram per mole, or let's say 1 mole of sodium chloride over 58.5 gram, or 58.5 gram is equal to 1 mole per sodium chloride. And therefore, this would be the calculations or the steps on how you calculate it. Mole of sodium chloride is equals to 29 gram times 1 mole of sodium chloride over 58.5 gram. So, cancel the units. We have the same here, gram. So, what you're gonna do, you have to multiply first 29 times 1. 29 times 1 is equals to what? 29. Then, after that one, you have to divide it into 58.5. So, 29 divided by 58.5 is equals to 0.496 or 0.50. We just round off it. Mole of sodium chloride, because the only unit that is left, we've already canceled the same unit, is mole of sodium chloride. So that makes the unit of the result. So again, the result would be 0.496 or 0.50. Okay, mole of sodium chloride. So I hope you get it. That if you have question clarifications, just direct message me or in group chat. Sige. So now let's proceed on another examples. What is the mass in grams of 2 moles of water? So here we have H2O, right? Again, in solving this problem, we must be able to cancel all units in the mole mass relationship except grams we are looking for. So given we have 2 moles of water or H2O. So eventually the molar mass of H2O is 18 gram, or where do we get the 18? Okay. So where do we get the 18 here? So we have to, again, we have to add the atomic weight of each element here. So we have 1 oxygen and 2 hydrogen. So meaning to say, one oxygen, so it is equivalent of 16 grams, right? Then, let's add it to a 2 hydrogen here. Can you see the subscript? Di ba may 2 dyan? Dalawa yung hydrogen natin. And that makes as the hydrogen or the atomic weight of an hydrogen would be 2. Kasi 1 plus 1 is equals to 2. So, 16 plus 2 is equals to 18 grams. So, that is the explanation where can we get 18 gram. Bakit siya naging 18 gram? Okay? Or 1 mole of H2O over 18 gram or 18 gram over 1 mole of H2O or water. So therefore, we have gram of H2O. Kasi here, we're not looking for the mole. We're looking for a gram, right? So equals to 2 moles of H2O. So where do we get this 2? That is actually given. Okay. 2 moles of H2O times 18 gram of H2O over 1 mole of H2O. So now cancel the same unit. We have moles of H2O and 1 mole of H2O. Cancel because it is the same unit. Then again, the process, you have to multiply 2 times 18, then divided 2 times 18. So 2 times 18, the result would be 36 gram of water. So here, as you can see, the differences between the first example and this example is that the first example, we're looking for a mole kasi the grams is already given. That's why we've canceled the unit of gram kasi given si gram. At ang hinihingi ay si mole. While here, we are looking for the gram. Okay? The only given is 2 moles of water. Okay? So, I hope you get the differences between the first example and the second example. Okay? So, now let's proceed. So, now let's solve word problem. So, this time, you will be the one to solve. So, just write your answer in a piece of paper, then picture it, then send it to my direct message it to my Facebook account, or if you can type it, pwede rin, and you can send it to my Gmail account, which is nikablancapihana@gmail.com. Okay, so let's solve. For number 1 question, how many moles are there in 42 grams of potassium bromide? Ito. Number 2, how many moles are there in 32.5 kilogram of barium chloride? And number 3, what is the mass in the grams of 6 moles of sodium bicarbonate? Okay? So that will be your task for today after you watch this lesson. Okay? I hope you get it. So before I will proceed to another topic for this morning, you observe here in the question number 2, we have kilograms. So I've already tell you if the units is not the same, so we have to convert it. And I've already discussed how to convert kilogram to gram. So here in number 2, you have to convert it. Okay? Take note with that. So now, let's proceed on molar volume. Since we've already discussed how to calculate a molar mass, let's proceed on molar volume. Okay? So, a mole has still another meaning. If we put 1 mole of any gas in an enclosed container, it will occupy a volume of 22.4 liters at a standard temperature and pressure of STP. STP is a 0 degrees Celsius in 1 atm. So, it literally explains that. So, meaning to say, if in the molar mass, the only concept would be 1 mole is equivalent to atomic weight. Here in molar volume, it is eventually explains that every 1 mole there is equivalent to a volume of gas. So literally, for instance, this would be what happened. So the concept of mole can be expressed in a molar volume as follows. We have 1 mole of hydrogen. 2 hydrogen gas occupies a volume of 22.4 liters at STP. As I've said, 1 mole of gas will be equivalent of volume of 1 volume. Yes, per volume. Yan. And 1 mole of helium gas occupies a volume of 22.4 liters, and 1 mole of chloride gas occupies a volume of 22.4 liters at STP. Again, here in 1 mole gas is always equivalent on the volume, equivalent per volume. Okay? So that is the differences between the molar mass, kasi molar mass is focused on the atomic weight, while here there is the involvement of the gas. Okay? So now let's go on the example. So how many moles are there in 5.6 liters of nitrogen gas at STP? So the given would be 5.6 liter of nitrogen at STP, and 1 mole of a gas occupies a volume of 22.4 L at STP. Or it is actually like this, 1 mole over 22.4 liter, or 22.4 liter over 1 mole. Okay, for the first question, the given is the liters. So here, we select the ratio that will cancel liters. So therefore, moles of nitrogen is equals to 5.6 liter, which is the given, times 1 mole of nitrogen over 22.4 liter. So now cancel the units. We have liter here. So now, since we've already canceled the units, so let's go with the process on how to calculate it. 5.6 liter, 5.6 times 1 is equals to 5.6. Over or divided by into 22.4, the result will be 0.25 mole, because the only unit is mole. So we're looking for a mole here because the liter is already given. So the answer will be 0.25 moles. Okay? I hope you get the point. Then, for example number 2, what is the volume in liters of 16 grams of oxygen gas at STP, or the standard temperature and pressure? So now here, the only given is the grams, not the liter. So literally, the given would be 16 grams of oxygen gas at standard temperature and pressure. Then the needed factors derived from mole concept would be 1 mole of oxygen gas over 32 gram, or 32 gram is over 1 mole of oxygen gas per liter, or B, 1 mole of oxygen gas over 22.4, or 22.4 liter over 1 mole of oxygen gas. Okay, so you will be asking along the discussion, Ma'am, where did you get the 32 gram? Dito, dito. Tingin, dito sa mole, sa letter A. So letter A would be the first step on calculating this question. So 32 gram is the result of oxygen gas. As you can see, we have a subscript 2 here. So you just add the atomic mass, or atomic weight, sorry. So 2 oxygen. So meaning to say 16 plus 16 is equals to 32. And the 22.4 here, as we all know, is always constant and given, because that is the formula for molar volume. 1 mole of gas is equivalent per 1 volume, and 1 volume is equivalent to 22.4 liter. That is in the first slide that I've already discussed. So now let's proceed. Let's calculate first the A before we will go on the liter, so that we can get the liter, or we can get the answer. So we select the factors that will cancel unnecessary units. So therefore, a mole of oxygen gas is equals to 16 gram of oxygen gas times 1 mole of oxygen gas over 32 gram of oxygen gas. So again, for the what do you call this? For the formula, or for the, always remember that we have to cancel the same units. So gram per oxygen and gram per oxygen cancel. So again, let's go with the process. 16 times 1 is 16 divided by 32 is equals to 0.5 mole. Okay, so that would be the answer, mole of oxygen gas. So now let's go on how we can get the liter. So the liter of oxygen gas is equals to 0.5 mole of oxygen gas times 22.4 liter over 1 mole of oxygen gas. So now let's cancel the same units. Then again, the same this literally the same process. 0.5 times 22.4 is equals to 11.2 divided by 1 is equals to 11.2 liters. So that would be the answer. So combination of A and B. So let's make it, let's combine it. The same lang man din to, and the answer would be 11.2 if you combine the process of letter A and B. So mole of oxygen gas is equals to 16 gram oxygen gas times 1 mole over 32 is equivalent to 0.5 mole. So 0.5 mole is times 22.4 equals over or divided by into 1 mole is equals to 11.2 liters. So that would be the answer for the example number 2. So what did you observe? The only difference between the two questions is that for the first question, the given would be liters, and you have to calculate the grams. While here, the only given is the grams, and you have to calculate the liter. So I hope you get the point on how can we get a molar volume. Okay? So now, any questions, clarifications with the two basic calculation on molar mass and molar volume. So you can erase that on GC, or you can direct message me. Don't forget your task today, ha? I will be waiting with that task until 12 midnight this day only. Okay? And now, let's solve the problem. So, continue your task. Meron pa itong question. This would be the pertaining to the molar volume naman to. I-continue na lang to. For number 4, how many moles are there in 3.2 liter of fluorine gas with atomic weight of 20.18? Number 5 is the volume in liters of 32 kilogram of helium gas at STP. So you just include it on your task. Okay? Let's proceed. So now, let's go on now to another topic for this morning. For this day would be molarity. Since the title of the lesson, the topic of our lesson is the molar mass, molar volume, and molarity. So let's go. So of course, let's back to basic. Let's define what is molarity. Refers to the number of moles of solute per liter of solution. It is expressed in moles, liter, and it gives the chemist an idea of exact number of molecules of solute present in 1 liter of a solution. How can we express the molarity? We can express it by volume of solution per or in liter. Okay, so that is the definition, or that explains what is molarity. So let's proceed. Molarity. So this is the constant. Formula for molarity is equals to number of moles divided by liters of solution, or molarity is equals to, okay, so the number of moles is over or divided volume. is equals to number of moles again over volume. So I just gave the symbol or the units of it. Remember guys that if it is in the capital letter M here, kasi capital letter M ang ginamit nating symbol, right? It is pertaining on molarity. But if we use small letter M, so here very crucial ito, lalo na sa exam or quizzes. Always remember na kapag capital M ang symbol na ginamit, meaning to say you are calculating molarity. Pero pag ginamit mo ang small letter M, meaning to say you are calculating molality. Okay? I hope did you get the point. Molarity is pertaining on the symbol capital letter M, and for the small letter M is the calculating for the term molality. We will discuss it furthermore in this subject. Okay? Yan lang yung kaibahan ni molarity and molality. So, take note with that kasi baka sa exam you will be using small. Wrong na agad yon in the formula. Okay? So, now let's proceed. So, how to calculate molarity? That is always a question. So, how? There is a steps or process or on how to calculate it. Calculating molarity with mole and volume. Example. What is the molarity of a solution containing 0.75 mole of sodium chloride in 4.2 liters? So, now, molarity is equals to mole of solute over liter of solution. So, example, mole. So, since the given would be, we have here a mole and we have also a volume which is 4.2. So, let's write first the given. Moles is equals to 0.75 mole sodium chloride. And for the volume, we have 4.2 liters. This is given nasa question yan. Okay, let's proceed. So now let's go on how to calculate it. So molarity is equals to 0.75 mole over 4.2 liter. Okay, then the answer would be 0.1785 7142. Why? Because we will just divide it. Okay? So, just divide 0.75 mole divided by 4.2 liter and the result would be 0.785742. But, we can round off it into 0.179 molarity of sodium chloride. Here, this is the result. Pareha lang po. Gi-round off lang po natin kasi ang kasunod ni 7 is 8. So, meaning to say, we have to round off it into 79. So, the answer would be 0.79 molarity of sodium chloride. Ma'am, where did we get the result? Just divide the mole and the liter, which is 0.75 divided by 4.2 liter. Okay? And there is no rule as i-cancel the units because it is not the same unit. Okay? Let's proceed. So, now here naman, another example for calculating molarity with mass and volume. Example problem. What is the molarity of a solution made by dissolving 3.4 gram of potassium manganese tetraoxide in 5.2 liters of water? Okay, so go back to again the same process. Molarity is equals to moles of solute over a liter of solution. Given we have 3.4 gram of potassium manganese tetraoxide, and for volume we have 5.2 liter. Okay, let's proceed. So here, so what we do, how do we get the 158 gram? Kasi we're looking with it also. So, from 158 gram is from the potassium, from the atomic mass of the potassium, the manganese, and the oxygen. Just add the atomic weight of them, but It is not the same in oxygen. Hindi pa yun ang result ng oxygen kasi may subscript 4 pa si oxygen here. That's why it's called tetraoxide kasi 4 na siya or may subscript 4 si oxygen. So, meaning to say, ika-apat. May 4 na oxygen tayo. So, from the 15.9994 or 16 times 4. So, you have to times that one. So, from the atomic weight of potassium, which is 39.0983 plus atomic weight of manganese, 54.938 plus the atomic weight of oxygen, which is 15.9994, just multiply it into 4. The result would be equals to 158.0339 or equals to 158 grams. So that's why we get the result, which is 158 grams. So let's go now on how to calculate it. 3.4 gram is given times 1 mole over 158 gram. So just cancel the same units. So 3.4 times 1 is equals to 3.4 divided by 158. So 3.4 divided by 158, the answer would be 0.0215 of mole. Okay? So that would be the answer. Okay? I hope you get the point. So the differences between the two example is that here, we're looking for the solution, the molarity of a solution from the giving dissolving object. The dissolving substances, of a liter of liters of water. In the first question naman, we are looking for the molarity, the same molarity of a solution in a mole and a liter. Okay? So I hope you get the point. So 0.0215 mole. And how can we get the molarity of it? We are just getting first the mole pa pala, kasi there is no mole here. No, as you can see, walang mole. So, from the formula of molarity here, mole of solute. So, walang mole, kaya gi-convert pa natin siya into mole, ang 2 gram na na-calculate natin. Sorry with that. So, now let's proceed on getting the molarity of the question number 2. So, molarity is equals to 0.0215 mole over 5.2 liter. It is actually given. So, the answer would be 0.004134615 or round off 0.004 molarity of potassium manganese tetraoxide. Okay, that would be the answer. So, let's go back Let's go back here. We just convert the gram to mole. Okay, ganito lang ang pag-convert nila. Kaya pala hindi pa molarity ang symbol dito kasi mole pa lang po to. Okay? Let me rephrase the explanation that I'm saying a while ago. This is pertaining to mole, then continue it on to molarity. So the answer for the question number 2 would be 0.04 molarity of potassium manganese tetraoxide. Okay? So I hope you understand the examples. Okay, let's proceed. So how do we determine the molarity of solution containing 4 grams of sodium of NaOH in 200 ml of solution? So the given would be mass of solute is equals to 4.0 gram. Volume of solution would be 200 ml. So write the formula of moles liter solution. So find the mass of NaOH. So here we are literally getting the mole. Again, the same with the first to the second example na kailangan muna natin kunin ng mole. So we have to get the atomic weight of the different element in the compound. We have sodium, we have 23, oxygen 16, and hydrogen, which is 1. So that will result as a 40. Add them, 23 plus 16 plus 1 is equals to 40 grams per mole. So that would be the result on the mole. Okay, let's proceed. So calculate the mole of NaOH is equals to 0.40 gram, which is constant, over 40 gram per mole, because that is the mole of the NaOH. We've already add the atomic weight of each element, is equals to 0.1 mole. Just divide it. So 4.0 divide 40 gram per mole. So again, always cancel the same unit, which is gram. So that makes it as a mole. 0.1 mole. So now change the volume, which is ml, to liter. How? By converting it. So 200 ml is divided by into 1000 ml. So there is a lot of conversion here in this calculation. So the answer would be 0.2 liter. So now let's calculate the molarity of the question here in this question. So molarity is equals to 0.1 mole over 0.2. So what would be the answer? So just divide 0.1 over 0.2. So the answer would be 0.5 molarity, or 0.5 mole per liter. Since we cannot cancel it kasi it is not the same unit. Okay? So I hope you understand the answer or the process on how to calculate it in this question. So there is a lot of conversion. If you can see ml here, you have to convert it into liter because that is on the formula. Okay? So now, let's proceed. Oh, okay, that would be the end of the slide. That would be the end of our lesson for this day. So I hope you understand the differences on how to calculate the molar mass, the molar volume, and the last would be molarity. If you have question clarification, you can ask me in GC, or you can direct message me. And do not forget your task for today. I will be still waiting until 12 midnight this day. Okay? So until 12 midnight lang siya. Kapag tomorrow na, I will be deducting 1 point each day na malate kayo. Okay? To be fair sa mga nagpasa ng on time. Okay? If there is no more question, thank you very much for watching the video. And if you did not understand it, you are free to watch it again. So that's why I make it pre-record for you to watch and watch and watch again, for you to easily understand the process in calculating the molar mass, molar volume, and the molarity. So thank you very much. Have a nice day, everyone.